All right, sorry for the delay. I still have an issue. I'm not sure if it's still an issue. We'll find out while I'm being recorded here. So I wanted to start by talking about the message that I sent out Sunday. And you can find what's relevant to that. If you go to pre-course, if you didn't see it, if you go to pre-course setup, I have this thing on VirtualBox and Vagrant. So there's I had already talked about that if you don't already, that you're probably going to want to get a virtual machine going with Linux on it. And there's a tool out there that can make it easy for people to deploy virtual machines kind of pre-configured and take a lot of the pain out of getting something like that all set up. So I took some time over the weekend to pull that together, and hopefully I've got it in place here. We're going to find out in a minute. You need to install VirtualBox. Now some of you may have, and the reason is because Vagrant's working with VirtualBox, and I'll talk about what Vagrant is in just a second. The reason VirtualBox and not VMware is that actually Vagrant works wonderfully with VMware, but they require a paid license if you want to integrate it with VMware, whereas you can use it open and free if you use VirtualBox. So I got it hooked up to VirtualBox there. And in order to use it, you do have to install VirtualBox. You do have to install Vagrant. Of course, just a quick Google search will turn up the Vagrant page, and you can see they got a download link. What Vagrant is it is a command line tool for managing hypervisors, which is the fancy nerdy term for saying virtual machines. Okay? And so I set up one of these. They also have a cloud where you can actually look at machines that other people have put up. So if you wanted an Ubuntu virtual machine, or you wanted some particular feature like a lamp stack, you can find people that have made a lamp stack. If you want one that has something to do with security, or you want a Apache, maybe Linux on it with the Apache web server on it, all tricked out and ready to go. You can find these boxes on there, and it's just simply a matter of using this command line tool, and it'll automate the process of grabbing that virtual box, getting it on your local machine, and being able to start it and stop it and all that. So let me show you the process of doing that. There's one other thing for those Windows users out there. If there's any of you using PuTTY, stop using PuTTY. You just don't do that. All right. MOBA Xterm is far better than PuTTY, and then this one I'm not a Windows guy, so I don't have my thumb on the pulse of what's cool and neat. Maybe all of you Windows folks know this, but to the extent you don't, there's a CMDER, which I assume you just say Commander, which is a console emulator that you can use in Windows, and it's got some Linux stuff already tricked out with it. So if you're using PuTTY or something else that feels a little kludgy, you might take a look at this. And I have a link to that at the top of this page here, which again is in the pre-course setup link. Let me make this a little bigger. If you're using a Mac, of course Macs have Unix under the hood, so you can just open up a terminal window, which you would find in the utilities under applications. You install VirtualBox, you install Vagrant. That should be pretty easy. You open up the terminal window or get that Commander thing going if you're on Windows. And this guy actually made a YouTube video on how to get all that stuff tricked out. So if you're in the Windows world and you have issues, you might take a look at this guy's video. You move into the directory where you want to do your work. So one of the nice things about Vagrant is you choose the directory kind of where you want to be working. You fire this thing up, and all of these, regardless of which of these thousands of boxes you choose, what they all have in common, they all have a Vagrant user. Its password is Vagrant, and it's got sudo privileges, and if you need to get directly into root on all the boxes is Vagrant. Okay. In addition, the directory that you're in when you kind of create and fire up this box is automatically mounted on that virtual machine. So that's why I made the statement to get CD on your local machine before you're dealing with virtual machines at all, on your local laptop. CD where you want to do all your work, and that's where you want to kind of fire up Vagrant, because that directory and any directories you create under it will be mounted and you can get free access to them in the virtual machine, which makes it nice for going back and forth. So let's say you're in your the Windows world and you're really sold on some sort of editor, programmer's editor that you have on Windows. Well, you can use that fine, and then you just write the files to that directory or some subdirectory, and you just flip over to your virtual machine and do compiling or whatever needs to be done on the Linux side, right? So anyway, enough of that. I provide a line here. Vagrant, of course, is the main command. It's got all sorts of subcommands in it. If you type Vagrant, you can see, whoops, didn't want to do that. There we go. All sorts of things you can do with Vagrant, and each one of these has a number of subcommands. So the thing that is out in the cloud that you can grab, they're calling a box. These are just the exported files of the virtual machine. And the first thing I'm having you do is this vagrant init. Let me talk about that command specifically. This is a very, very shallow command. Very little is being done. It's saying that it put a vagrant file named vagrant file has been placed in this directory. Oh, actually, I don't want it here. Hang on. Let me do it again. All right. Oh, let me get rid of it. Okay. Third time. There we go. All this does is it literally just puts a text file in the directory you are currently sitting in. You can open it up. In fact, you're expected to edit it once you're familiar with Vagrant. You want to trick out the box you're working with. All sorts of commands you can stick in here. For this class, we need to have a graphical interface for the GPL stuff that we look at, right? Now let me pause right here and say, after today, we aren't going to need a graphical user interface for the GPL widgets for at least half the semester. We're going to just be working in a text editor, compiling, right? It isn't until we get pretty far down the line that we actually turn the switch on to the graphics and we start dealing with that portion of this language. So setting that aside, I do want it today because I thought we'd check out some of your games. And what I ask you to do is go in that file and edit it, and I ask you to put in these 3 lines before the final end. So like I'm also teaching a systems programming class. We don't have any need for a GUI, so you can easily run this thing without having a GUI. But rather than copying and pasting these 3 lines, which you'd be fine doing, it turns out in some of this discussion that they have in these comments, they show you what you need. So you need this line, you need that line, and you need that line. There you go. So comment out those, uncomment those 3 lines, and you'll do the same thing as pasting in these 3 lines. They're the same. And you can just read it and see that obviously it's just allowing a graphical interface to pop up when you work with Vagrant. All right. So after you do that, it's asking you to add the box, and this right here, you could actually skip this step, but let me, if you type this and had forgotten to do this, this will automatically do this if necessary. So this will go out into the cloud there to Vagrant's site, and it'll grab a copy of that virtual machine, and it'll just store it in a private location. There's a dot file if you're on a Mac. I don't know what it does exactly with Windows, but in the Mac world or in the Linux world, if you're doing this, it'll have a .vagrant _d directory in your home directory, and it'll store all of its information there. After you get that box locally, you just say vagrant up. So again, vagrant up's intelligent. If you don't already have a copy of the box, it's going to go out there and grab it. But the first thing it does is it looks to see if you have it locally. So either way, I didn't want to. It is a good gig and a half in size. So I didn't want to take that time to show you what it's like to download something. I'm sure you've all seen that. So I've already got it. Incidentally, that's not in this write-up anywhere, but if you wanted to see the boxes that it had gotten off the web, or in my case, I was building them locally, so I loaded up some boxes locally without getting on Vagrant's site to grab them. If you say, you don't say ls-l, you say Vagrant box list, and it looks like I've got 1, 2, 3, 4 boxes. Now these are, I don't know what word to use, these are abstract, these are not instantiated. I can instantiate as many Todd Gibson for 515 machines as I want, right? These aren't running machines, these are just the templates, the files that are used to instantiate and create an instance of a virtual machine. So anyway, the command to bring it up is vagrant up. This will, if the machine is not downloaded, it downloads it. Second step, if there's not an instance of the machine in VirtualBox, it will bring it into VirtualBox. That's what it's doing right now. Once it does those two checks, so 99% of the time, right, you're only going to do this stuff once, 99% of the time, it's already there. Boots it up. Boot process is a little bit silent, so we just stare at a blank screen for a bit. And then it's up. Now this, sometimes it takes a little bit longer, and every once in a blue moon I get a black screen here, and there's just some funky refresh problem with VirtualBox, that it isn't giving me the screen right away. You have a couple choices. You can bring the machine down and bring it back up and the problem's solved, or you can do a couple key commands. Let me see, what should I, let me do it the easy way. Let me say vagrant halt. Let me try it this way. Again, most of the time you won't have that issue, and then you just bring it back up. All right. You see this, go ahead and hit use default config. You only need to do that once each time you create a brand new virtual machine. You don't have, you're welcome to use this interface however you want. You can open up terminals and you can do development in here, right? It's a proper virtual machine, but you don't have to unless you get some particular thrill out of it. For instance, myself, I like doing everything from this terminal window here. So let's, for the sake of argument, let's pretend this isn't here. Let's pretend we're in 540 where there is no graphical interface. For me to actually get into this machine is as simple as saying vagrant SSH, and it will secure shell me into the machine. So now I'm on this virtual machine that we see back here. There's nothing in the home directory. Again, I'm the vagrant user. Vagrant's the password. If I wanted to get in as, it has full sudo privileges, but if I wanted to be root, root's password is vagrant. All right. To look at, let me see if I've got, let me exit out of there. All right. On the right side is my virtual machine. On the left side is my Mac, and here's that vagrant file right there. Here, there's a directory on all these machines, regardless of whose it is, /vagrant. And that is what's mounted. Let me actually CD there. So if I wanted to do work actually through this secure shell here, I just say cd/vagrant. Now I've got that whole hierarchy from the point where I created the virtual machine to work on, right? And there it is on Linux, or excuse me, on the Mac. Again, of course, the reason I have this here is so that we can do stuff like from inside the virtual machine. I can say, I can run one of these executables, and I can run breakout. Let me see, maybe we make this a little bigger. That grows a little bigger. And there we go. Q to quit, come back here, right? When you're done working for the day, just exit out if you're shelled in anywhere. Of course, you can create as many shell windows as you want into it. You saw that you can do vagrant halt. What vagrant halt is doing is it's doing exactly what you do when you shut down a Linux box. It's gracefully asking it to go through its shutdown routine, and it'll halt the box and disappear. If you don't want to take that time, so there's definitely several seconds for the virtual machine to start up and go through its initialization scripts and all the wonderful things that Linux does when it's starting up. Just like virtual machines, you can basically just tell it to suspend, right? Just freeze the state. You can do that. Vagrant, suspend. There we go. We're suspended. And now when you're ready to come back and bring it up, vagrant up. And it just simply unsuspends it. And there we are. Okay. So for those of you who are wrestling with the virtual machine stuff, I think this might be a good option for you to try. A lot more painless. Any questions on that? Okay. All right. So you all put together some games. And where did I put that? Why is it in a golden color? I'm not quite sure why that is. Maybe it's saying that it has full permissions, so it's frightened. Anyone want to volunteer and show off their game? I know, come on, some of you got some kick-ass stuff going here. Let's have a look. Yeah, come on up. What's your ID?
P1.
All right, so let me see. Where are we? So we're going to have to go ... And it is Disco Snake?
Yep.
All right. Let me actually... You go ahead and drive and tell us what's happening in case... Oops.
Oh.
That's because, I'm sorry, that's on my Mac. I need to be in my virtual machine. So let me do that again. Vagrant SSH. And now I'll go down to wherever the hell I was. 2019-01-20 CD/vagrant. All right, there's where it all is. CD 2019-01-29 games. Elund. There's the executable and Disco Snake. And then we can just quickly come over here. All right. So reminiscent of the disco floors from the 70s, no doubt, is what inspired the title.
Dang it.
Little uh-oh, all right.
Didn't want to have a too rude of a failure message. We're all just trying our best.
That's right.
Go. Go. And the win condition in the corner there, it does work, but I'm not good enough to beat this game.
All right.
But I tested it by cheating, so it does work.
Good. All right. Great. Thank you. Appreciate it. All right. Anyone willing to hold their head high after seeing that Michelangelo bit of sculpture there? Yeah, come on up. Yeah, it doesn't matter. I'll have you both come up.
Basically made a worse version of Pac-Man.
And I'll let you go ahead and navigate yourself in there. And then you're going to have to go three parents up. I don't think GPL's in the path, so we're going to have to go. Oh, here you go. All right, now you can hold on.
And
over.
hopefully it doesn't.
Oh, that's cool.
And basically the points go up 100 everything, and then once you get all of them, the points just start going up over time until you, and then you get a game over.
All right, great. Yeah, that's great. Thanks, appreciate that. All right.
I have a quick question.
Yeah.
Were your enemies deterministic, or were they?
It was all random.
Cool.
Yeah, they were all just, every time they got to a corner,
Yeah.
they would choose a direction depending on the options.
You got too many dots.
Oh, I sure do.
Just type AR and hit tab. There you go. You got it. Click on the green background there.
Oh, there it is. Okay, so this is just my take on Pong, basically. It has 3 projectiles. You can play it and hit them.
Is that supposed to be a bumper or an eyeball or?
It's supposed to be an eyeball, but it's really badly drawn.
Oh,
But-
I was able to.
Yeah.
Oh, and you can even move the paddle up.
Yeah, you can move the paddle up and down, and if the projectile hits the bottom, it increases the velocity, and it lowers your score because you should be punished for missing.
Oh, great.
Anyway, that's it.
Good. All right. Good job. Anyone else willing? Yeah, come on.
I have a bunch of extra files that come along with it. So,
Are they in there?
they don't have to be downloaded. I have to use a flash drive.
Well, we can download them. Are you able to download them from here? All right. So what? Yeah, come on over. So what's your ID? Oh, so you need to get the GPL as well.
Okay.
Is that right? And you're able to get them what, through a web interface?
I have them on my flash drive.
Oh, all right. So see, this is how you get a keylogger on the instructor's computer, by the way. All right. So let's see what we got here. Is it my game, I assume?
It's everything in that folder.
And this is how the instructor can figure out what you have to say to your mom. So CD into 219, 01, come on, 0129 games. And then I want to copy, we can do it this way. Let me see what's in there. Is it all flat, or do we have directories in there? So you need the assets directory as well?
Yeah.
Okay, so let me CD in there, RCF, everything, pipe into CD into Chica courses 515. Oops, what's going on here? It's 19, 2019, 01, 29. Games. Tar, XF. CD. This thing's complaining with both virtual machines, a thumb drive, and a recording going on all at once. So that's not working. Let me come up here. Let me come there. Up one more maybe. That's what I wanted. Eject. Did I forget? No. All right. That's when you get impatient. That happens. And we come back here, and we do an LS, and there you go.
Cool.
So you just type in whatever needs to be typed in to start running it. That's the executable there, the GPL executable. And then just be sure to click over to the screen behind after you hit enter.
Whoa. So can you right click or left click with this thing?
You know, you have to have like hold down control and click. Sorry, I don't have my 3-button mouse with me. Oh, there we go. So you command click, is that it?
Yeah. I got a mouse. Plug it in. Okay, so yeah, movement is with the right mouse, and you can shoot
So you
back
do
and
those
back.
graphics yourself?
Yeah. It's a lot harder on your computer.
So so you're just clicking on the bats before they reach you? Is that it?
No, it actually shoots out a little projectile.
Oh, okay. It's just hard to see.
Yeah, it runs a lot faster than that.
Right. So this would be a case we have to go in there and set the
Animation speed much better.
yeah.
Yeah.
Boy, that's cool. So
Yeah.
you created different frames for that person spinning around with the following the mouse.
Yeah.
Holy smokes, you put a lot of work into this.
Yeah, that's pretty much it.
Yeah, that's good. Yeah, you have a question?
Yeah, just how did you make it so smooth? If I always do background, you smooth.
That's kind of a hack. That's what the black border is there for. I invented like another coordinate system the character sits on, and then I move it around the coordinate system and move all the sprites around in relation to that. Yeah.
Yeah, that's good. That's good. All right. Excellent work. Good job. All right, so let's see, how many lines of code did that take? 473, that's it? Wow, all right. I'm doubly impressed. I mean, that's far better than that World War II piece of garbage, and they had more than twice as many lines as yours. Okay. Let's study that tonight, figure out how to do that. All right, so what do we want to talk about today? I think what I need to spend a little bit of time talking about the compiling process. It's because it really, we're going to be doing some pretty deep development, and to have a good understanding of how things are actually compiled, I think is useful. So when I ask what's the compiling process, who has any idea what the answer would be? How many steps are there when you compile a program? Now I know there's at least one, so you hit G++ and you hit enter, something comes out the other end, so there's one, but you subdivide that. What are the three? Let me see, compiling, steps, let's call it compiling, .text for notes. So the steps to compiling, All right, 1, 2, 3, what are those three steps? Preprocessor, postprocessor, no, what else? Oh, let me see, I'll do it as nouns rather than verbs. So compiler, There's one more step. I'm going to call that 4. What's 3? Assembler. Does anyone ever divided those up in your Hello World program? Let's give it a go. In fact, let's not start with Hello World. Let's start with rhyme. With fleece as white as snow. I don't want to call that rhyme.text. Let me call that move rhyme.text to rhyme. Let's say that's H. Let's create a rhyme.c. I'm going to work in C rather than C++. C++ does a lot of name mangling and so forth that just makes it more turgid to talk about, so it'll be a little cleaner discussion. But anything that I talk about here applies equally to C++. Mary had a little lamb. Count include. Rhyme.h. The first thing you need to notice about this, one, is I haven't typed in any code. Because I'm not going to compile this. All I'm going to do cd, let me see. All right, bring both of these up here. All I want to do right now is run the preprocessor. So anything that begins with a pound is a preprocessor directive by definition. If it does not start with a pound, the preprocessor ignores it. So one way to look at the preprocessor, it's more complicated than this, but we all familiar with cat, the concatenate command in Linux. I can say cat compiling.text, and that simply spits it out to the screen. Okay, that's all the preprocessor is doing, in that it's taking that file and it's just spitting the contents back out to standard out to the screen if you'd let it. But if it encounters a line that begins with a pound sign, then it immediately does work. It interprets that as a command for it to process. Okay? And of course the one we're most familiar with is include. And one thing to note, I think there's a silent assumption, and a lot of people haven't thought it through and realize it, but include statements don't have to go at the top of a file. That's by convention, right? The preprocessor doesn't care. You can put them wherever you want. Other preprocessor symbols that you're most likely have seen are the header guards, as they call them, the pound def, pound define, pound endif that you put at the top and bottom of header files. Do you know why you do that? Okay, so having the same include statement twice, it prevents that from happening. Right. Okay. GCC, again, we could use G++. I'm gonna, you know what I'm gonna do is I'm gonna change this prompt so I have a little more real estate to type commands. So I'm gonna say PS1 equals, I want to say VN dollars so that I know this is the virtual machine that I'm on. G++ -e is I'll leave this as kind of incomplete, but you would say that -e is only run the preprocessor. Another way I like to state it is when you type G++ or GCC, it runs through this whole workflow of 4 things. So what -e is doing is it's suppressing anything after the preprocessor, I think is a nicer way of looking at it. And now I'm going on memory. Well, let me first put this out and see what it does. I think what I want to do is I want to suppress all of those extra pound signs. There we go. The -p will suppress all those extra pound signs. I'll talk about those in a moment. So we can see what the preprocessor did is it did just like cat does, is it just took in lines and spit them back out. However, when it hit that pound include statement, it then went inside that file, opened it up, and did the same thing, was just spitting out its contents unless it found something that started with a pound to do some sort of behavior, right? So sometimes you hear people saying, well, the preprocessor isn't really part of the language, and that's where this comes from, in that the preprocessor has its own set of directives that it follows, but really it doesn't care whether you got C++ or C or nursery rhymes, right? It's just taking it in and spitting it out. These, incidentally, are information, pieces of information that go on to the compiler. Because what is it that the compiler is seeing then? I mean, this is what the compiler sees, right? Not this rhyme, but you get the idea. You've written a program, you got some pound include statements in there. All it is seeing is a stream of text. Okay? The compiler is just processing a stream of text. The compiler is not opening up header files. It's not dealing with the if, def, end, def. By the time the compiler gets it, it's nothing but a stream of text. Well, how is it, if I do try compiling this, oops, let me, if the compiler gets nothing but a stream of text, how in the hell did it know that it had an error in a file called rhyme.c and that it was on line 1? In fact, let's make the mystery deeper. Since I know that isn't going to compile, let me do that. Actually, I don't know if that'll work with the C compiler. GCC rhyme.c. Now it's saying there's a problem in rhyme.h. So the question is, well, you and I both know that that is all the compiler was seeing. How did it know that this was in rhyme.h? And that's what this -p is that I'm suppressing. So let me go back and bring up rhyme.c and uncomment that. And let's look at that output again without the -p. So the -p cleaned it up so that we could just see stuff we want to see. But all of these things that begin with a pound after it's gone through the preprocessor, these are no longer preprocessor directives. They're information that the preprocessor is providing to the compiler. So the compiler gobbles this stuff up, and you'll notice right here, it is saying, hey compiler, you're about to see line 1 of a file called rhyme.c. And then it hits this, and then we got an error, and the compiler knew to say the error was in line 1 of rhyme.c. But then I had commented out, and it said that it was an error on rhyme.h, and the reason is it thought it was in rhyme.c. This ended up being a comment that it didn't do anything with. Then it hit this line, and this is information for the compiler saying, now you're about to process line 1 and subsequent lines of rhyme.h. Then it hit this line, had an error, so it was able to correctly report that the problem was here. We can mess with that. Let me let me come here. Now, I don't do this very frequently, so it may take me a couple tries. Let me introduce a bug. That isn't going to be a bug. Let me introduce a bug here. I'll put a comma there instead of a semicolon. I'm not even sure what the error is going to be. Let's find out. G++, hello.cpp. So again, it knew it was in hello.cpp, and it knew it was on line 8, because there's one of those pounds that said hello.cpp line 1, and then 8 lines later it found the error, right? Let me go in there. So again, I'm going to have to experiment just a little bit. So I don't quite remember. All right, so that's it. This is stays 1. This becomes 99. My error is now in file hello.fdsa on line 101. Because what I did is I fooled the compiler by providing one of these things that the preprocessor normally provides. Now, the preprocessor did provide it. If we looked at that big long stream of stuff it produced, we can look at that big long stream. Let's look at the big long stream. Minus E. Why was there so much stuff? IO stream, yeah. But here you go. So it said, okay, way up there it said line 1 of hello.cpp, and then it said it was jumping into line 1 of IOStream. IOStream probably included a bunch of stuff, so there's probably a bunch more of those. Eventually it fell out, and now it's saying, again, this is one long stream that the compiler gets. The compiler sees this and goes, aha, now I'm on line 2 of hello.cpp. Now I'm on line 3 of hello.cpp. This is line 4, line 5, line 6, line 7, and then it says, aha, now I'm on line 99 of a brand new file called hello.fdsa. And that's line 100 of FDSA, or maybe this is 99, and then 100 and 101 is where it reported the error. Okay, so you didn't hear it here, but when you got someone you're working with and you got 4 or 5 files that have hundreds of lines, just introduce an error into one of them. And whoops, CPP. So you've got dozens of files, hundreds of lines, or whatever it is, 5 files and hundreds of lines. You go stick this in, create a syntax error, and put this right next to it. Now they're going to compile their project. And they're going to go to the wrong file, and they're going to be staring at line 99 for hours. Yeah. So I can tell you from experience, you do not win friends this way. But it does put a smile on your face. So go ahead and use that if you want. Oops, I got that wrong. What did I say? No, I didn't get, this one needed to stay, I needed to do this, sorry. Leave that one as a 1. Let me try it again. I mean, you got the point, but there you go. All right, that looks normal. So they'll never be looking in hello.cpp. They're going to be looking in the other file.cpp. All right. So where are we? What are we talking about here? Compiling. All right, let me bring that back up. The compiler. Anyone remember the option? That's there. S. It's uppercase, isn't it? All right, we're going to find out. So let me see. Let me go to my hello.cpp. I'm going to change this back to just create a silly little function here. I guess I should be leaving. I'm going to do this. I'll leave this one in place since it has the nasty trick. And in fact, we'll rename this move hello.cpp nasty trick.cpp. And then vim whatever, some file.cpp. And I didn't want to call it move some file. Let me make it a C file. And I can say int xyz equals 20, xyz equals xyz, excuse me, add 5 xyz. All right. Not a fancy bit of code, but we can go ahead. Let me get into my virtual machine here. /vagrant. There you go. Oh yeah, where I wanted to say GCC, I think it's a -s, an uppercase -s, some file. Got my comma in there still. All right, there we go. All right, so this one, the preprocessor is the one that's spitting right back to standard out and is piped into the compiler. The compiler generates assembly language, and we see that right here with the S extension. We can look at that. And you don't even need to be able to read assembly language to be able to kind of pull this apart with your eyes. Here's the main function. Starting here, we can see that right here is the call to the add 5 function, and if I look for that further up in the file, we can see here's the add 5 function, right? So that is what gets sent on in the compiling process. That assembly language gets passed to the assembler, and then what everyone's learned since 1.11 is when you're compiling several files at once, you generally use a makefile, and what you do is you add the -c option for each of your CPP files. So you if you add 5 CPP files, you end up with 5.0 files, right? So what I want to do is say, I'm going to change this, that's obvious. This becomes to standard out. This becomes a .s file. This becomes an object file. And then, of course, if you don't add anything, then this becomes the executable. What are executables called by default? A.out. Why is it called A.out? This is your answer. So this is history. Assembler output, right? That's the pedigree of that naming convention. So why is it that these steps are being broken up? Specifically, I'm not so concerned. The E and the S is interesting for understanding, but the C, we're using to get useful work done. Why are we going to the trouble of building object files before linking them together? Why don't we just say G++ star.cpp and compile all of them? Let me actually ask a different question. If I am doing it the old 111 way, the stuff that we talked about there on the left side is not being avoided by the compiler. The compiler has to go through these steps. And in the case of 1.cpp, 2.cpp, 3.cpp, it has to do steps 1 through 3, steps 1 through 3, steps 1 through 3, and then it does a single step 4. Okay, so there's no free lunch. It isn't that we get to break those up and separate them. It's that that's the only way things can be compiled, is the compiler, and it has to start up, run through the preprocessor, a bunch of standard output, goes through the compiler. Assuming it's fine, it generates its output file. It then invokes the assembler, and then it stops. That whole flow stops. Everything completely dies, and then once again it gets a new file. The preprocessor starts up. Its output is piped into the compiler. The compiler generates an assembly file. That is given to the assembler. The assembler turns it to object code. It stops. Everything dies. Process begins all over again. Stops. Everything dies, and then the linker is invoked to tie all these .o files together. It's really good to understand this when you are troubleshooting and debugging. So if I let me come into my sum file here, and let's say I was going to call a function. Now, first of all, I do need a prototype for this function. We'll talk more about that in a minute. So this is my function prototype or declaration. This I would be calling a function definition. Let's see, how do I want to do this? So do that. Yeah, can't get it all there. It's probably not worth it. All right. Let me quit out of this and let me compile. Got an error. Let me quickly bring up the file again. Are there any problems with the preprocessor? No, it works just fine. It made it through that. Is there any problems with the compiler? Here's the question. Is there any problems compiling this? Can this be turned into assembly code? Let's try it out. GCC, we only want to go as far as the assembler, so I do it uppercase S, and I do it on sumfile.c. No error at all. It actually compiled just fine. There's nothing wrong with that as far as C++ is concerned. Let's look at the assembly code. Again, we don't have to get hung up on what exactly it's doing. It's sufficient to see, aha, there's our call to add 5, and there's our call to add 10. And here is the code for add 5. Note, however, let me do add 5 is there. If I look at this one, where's my add 10? That's the only place in this whole file that exists. Okay. So the assembler's job, the linker's job, is to link together calls to functions with their definitions. Now, it's pretty easy if it's all in one file. It's all in this bit of assembly code here. So there's not a lot of linking to do. However, I could have my add10 in a totally different file. So if I call this my add10 func, and it was integer add10, integer now I've got to do this kind of thing that we have over here on the left. Oh, we can actually compile that up through the assembler on that one as well. So let me do this and change this to the add10 func. Now I should have an add10 func.s. Oh, I'm sorry, I used... oh, that's because I have the wrong extension. Sorry, I wanted to avoid getting into those weeds. Let me do it again. All right, add10.s. Here's this one. The only thing missing from this one is somewhere a bit of code that says call add10, blah, 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 right? So I can assemble them. Got through the compiler. I can assemble them as well, so I do the -c. So I get through all three steps just fine. Now it's the linker's job to find all those calls and marry them up with the source to those functions. That's what the linker's doing. And it's linking together the call that is in some file.o with the source, the compiled source to that function in this object file, right? That's the linker's job. So it's very key to understand where your errors are coming from in this process. My original attempt to compile was, whoops, it was this one. Who's complaining of these 4 steps? The linker, right? It did the other 3 just fine. We compiled it with a -c just a few moments ago, so it got through the preprocessor, compiler, assembler. The linker is complaining. Your clue here is LD is Linux's name for the linking for the application. It's an actual ls-l user bin sort is a function you may have used, right? That's an executable file. ls is an executable file, and so is ld. It's just an executable file that's getting run. So really, G++, when you type G++, it isn't some monolithic compiler. G++ is kind of a middleman managing a pipeline, right? G++ is taking this, shoving it through the preprocessor, taking the result, shoving it into the assembler, taking into the compiler, into the assembler, and then it's taking all those .o files and it's invoking LD, providing all the .o files. There's no way to get around creating the .o files. Look very carefully at this error. Right here. The GCC actually created a .o file for some file.c, and that's what it called it. It put it in a temporary directory. If you were to compile 20 of these things, it would put 20 of them in this temporary directory, and then it would call LD, and if you were to look at the command line arguments, you would see 20 .o files in the temp directory being passed to it to create an executable from it. Okay? So understanding where your errors are coming from really helps your ability to debug things. How do you create a, what about errors in these other places? How do you create a preprocessor error? What do you think?
Directed with bad syntax.
Yeah, directed with bad syntax. So how about pound, blah, blah, blah. Yeah? There you go. That's an invalid preprocessing directive. That's a preprocessor complaining. This one's easy. The people who are most adept at this, or the 111 students, is the compiler error. All right? I mean, you can't avoid them. So most of the errors that you see in 111 are coming from here. A little bit later on, when you start dealing with multiple files, you start seeing linker errors. And that's a key thing that 111 students suffer from, is they don't understand this workflow. So when they're looking at it, they just see an error, and they see a linker error, and then they open up their file and they're staring at their C++ code, when the problem probably isn't their C++ code. The problem is that the linker probably didn't get all the object files it needed to create a working application. Let me simplify this. Let me comment out this line. So now this is written. Well, here's a question. Does it work fine? What I'm going to do, actually, let me put it back just to get to where we were. Okay. Error, we're trying to call the add10 function, and the linker doesn't know where to find it. Let me comment that out. Let's not use the add10 function. What about this, though? I'm not removing that. Is that going to create a problem? I hear no. All right. You're being put on the spot. Let's see whether you're going to hold your head in shame. No! All right. You're safe. So, what? We just gave a prototype to a function, and we didn't use that function. That's not a problem. What's the purpose of a prototype? Or let me ask a different question. Who in this pipeline cares about prototypes? The compiler cares about prototypes. The way to look at prototypes are as information for the compiler. Nothing more. You're not creating anything. You're informing the compiler. What we're saying on line 2 is there is a function. It's called add10. It returns an integer. It takes an integer as an argument. Should you decide to use it, you got to make sure it's used this way. Let's use it a different way. Let's make this all uppercase. Okay, we get, this is C. C allows implicit declarations, so C's screwing me up. It's a little more loosey-goosey than C++. C++ would give you an error, and it would just simply say, hey, I've never seen that before. Well, I got the prototype there. No, you have the prototype for a totally different function. Or if you do, how about, let's try a different way of using it correctly. Pass in a string instead of an integer. Another compiler error. It's basically saying you're using the function incorrectly. So this is nothing more than information for the compiler to help you as programmers use things correctly. And now, so I've got this in a different file, and we know that once I use it correctly, and I have all files, so the linker's happy. So I say gcc -c somefile.c, gcc-c, wake up to add10.c, and then I can say and it even though I say GCC, what it does is it sees nothing but .os, so it skips this step, skips this step, skips this step, and immediately invokes the linker, passing in these two files as arguments. Okay. But this is error prone because my application is now growing. And actually, let me pause for a moment and drive this home. It's information for the compiler. Should you decide to use it, you're under no obligation to use it. The best example of this is when you pound include IO stream. We saw that it was a lot of lines of code. If you look at it, it's about 20,000 lines of code. Actually, it adds a lot of that post-preprocessor stuff. It's probably closer to 10,000 lines. Still a lot of code. When you pound include IO stream, what you're doing is you're telling the compiler, hey, here's how all the facilities of input and output work. Should you decide to use all of them, here's how they all work. But of course, you're not under any obligation to use every single facility provided by input and output, right? It's information for the compiler. You're not obliged to use that information. So the next question is, why header files? And the reason is, if my application grows and I have 100 different C files, and in those 100 different files, they all want to use add 10. Well, that means that I have to provide this prototype in 100 different places at the top of my C files, or at least not at the top, but at least before I use it. And that's error prone because I can get typos in there and so on and so forth. So the idea is, rather than having all your declarations in every file where you use the function, put all those in a single file, and we'll just include it wherever we need it, whenever we need to tell the compiler about those functions. Okay, and so that is the underlying reason for why we have header files. All right. So, any questions? Yeah.
So if something, like some languages don't use header files, they multi-pass. So how does that work?
I couldn't tell you exactly. Generally, with multipass, it's either in main memory, just keeping track of things, or it's building temporary files along the way. It certainly depends on what the language is. Unfortunately, I don't have any specific information examples to offer. But that would be the strategy. Either in multiple passes, if the process isn't ending, it's clearly keeping either it in main memory or it's building temporary files, intermediate stages. So I think that this is a good place to stop. We'll hit the ground looking at scanning, and we'll do an in-class assignment and then something to do over the weekend after tomorrow. And then when we run into compiling problems throughout the semester, hopefully this will help you hone in on that stuff more quickly. All right.